So in this video, we basically discuss on a strain hardening. So in a stress strain diagram, we basically observe the strain hardening phenomena. So at first we draw the stress strain diagram. So this is basically the stress strain diagram. So this is basically upper yield point and this is the lower yield point. So and here we have basically the elastic. It is basically the elastic region, and from just here, like this region to somewhere this, it is basically known as a plastic plastic region. And here we get a particular point that is basically known as ultimate stress. From when the ultimate stress is crossed, then we basically get the necking, and after necking we get the fracture. So we get a necking after when the ultimate stress is caused, then we get a necking, then we get the fracture. So first of all, we have to know what is the yield point, what is the yield point, or what is the yield stress. So yield stress, it is basically the minimum stress when if we have a particular hot and plastically deformed metal. In that particular metal we basically apply the force. These force basically create the stress inside that particular the metal. So if that particular stress is cross the yield stress, then the thing will be happen, then actually the properties of the metal should be changed, like elastic to the plastic. So it is basically the yield stress. It is a basically minimum stress which is required for a particular the particular metal. When that particular minimum stress is crossed, then that particular metal properties should getting changed, like elastic to plastic. So this is the minimum stress which is required that particular metal. So it is the basically the minimum stress which is basically required by the metal to change its phase, like elastic to plastic. So now, so it is basically the 2 point, the yielding point. So when that particular yield stress will be crossed, then we get the strain hardening. So this particular area, we can say the strain hardening. So strain hardening, another term name is work hardening. So strain hardening or the work hardening. So what we get, what actually happen in a strain hardening and a work hardening. In a strain hardening, we have a basically the metal property should be changed, like elastic to plastic. So we get a particular metal stock which is already the plastically deformed, and in a plastically deformed metal, and simultaneously we also, because of the force, we there have a little modification in a grain structure. So in this particular region we get the fine grain structure. In this particular region we get the fine grain structure. So in this particular area we basically get the fine grain structure. So here we basically get the fine grain structure, and simultaneously there have a one fine grain structure, there have a one problem. And the problem is that the fine grain structure, not we get the only the fine grain structure, actually we also get the another thing that is known as a dislocation. We basically get the two thing in this particular region. We get a two thing. One is basically the fine grain structure, and second thing is basically known as a dislocation. So the problem is that the fine grain structure does not allow this dislocation to not move. So in a fine grain structure, dislocation are not able to move. So as the dislocation are not starting move, so because of that, like the properties should be the changed. The properties like the strength, the hardness, the toughness, these are basically increased. So strength and hardness will be increased, but the ductile property, the malleable property, so these are basically decreased. And ductile property, malleable property, so these are basically decreased. So now increasing this particular ductile property and the malleable property, that time again we provide the heat over here. We provide the heat. So when, because of that particular heat, the grain structure will be again change, and we basically get the coarse grain structure. when we provide the heat, so because of that particular heat, we basically get and the second particular step, we basically get the coarse grain structure. So coarse grain structure, and this coarse grain structure allow this location in a coarse grain structure like start moving here and there. So here basically the dislocation are moving and a coarse grain structure. So as the dislocation start moving, so that time what actually happen, this the strength, the hardness property will be decreased, but ductile property, the malleable property, this will be increased. So this is the reverse phenomena will be happen. So now increasing the strength, that time the increasing the strength, that time we basically do certain thing, that is basically we call the strengthening of the metal. So the next video we basically discuss on that particular topic.